Hello, and welcome to Lesson 5 of the Maintenance and Reliability Professional Review course, Equipment Reliability 2. This slide shows various means for contacting me. Again, my name is Dave Krings, and I'll be your instructor for the entire program through Lesson 9. The best way to contact me, as I've mentioned before, is through my email address at dkrings@masteringmaintenance.com. The objective for today is to continue on with Pillar 3 of the SMRP standard, which is equipment reliability. Lesson 4 covered this pillar as well. Just as a refresher, this is a two-part objective. First, we're going to assess the current capabilities of the equipment and processes in terms of their reliability, availability, maintainability, and criticality. And second, we're going to select and apply the most appropriate maintenance practices for equipment to deliver their intended capabilities in the safest, most cost-effective manner. The agenda for today's lesson, Equipment Reliability 2, is as follows. First, we're going to design a maintenance strategy to assure performance, which is a continuation of what we were discussing at the end of Lesson 4. Second, we're going to justify tactics for implementation. Third, we're going to apply workflow process and maintenance strategy. Fourth, we're going to measure performance and adjust for maximum return. The now familiar 5 pillars slide shows a couple of different depictions of the model for the 5 pillars. We continue to discuss the third pillar, equipment reliability, shown in pale green in both diagrams. The first objective for today is to establish a maintenance strategy to assure performance. This is a continuation of the same topic from Lesson 4. We're going to select tactics to meet the targets and close the gaps. If you remember, we identified what the gaps were in Lesson 4. Again, this is a very common theme throughout the program. For equipment, apply best practices to assure maximum reliability. In the first case, this would be during initial design, a long time before the equipment's in operation. This is the best place to begin working on reliability improvement. So during initial design, there are things that we should do to make sure that the equipment will be reliable when it's in operation. We want to make sure that we assure the ease of maintenance. We make sure that the piece of equipment is installed in such a way that it's easy to access, easy to work on, easy to see what you're doing, and there's enough room to get in there and do the work. Second, we want to maximize process and component reliability. So we want to buy equipment that's going to be reliable, it's well known for being a long live piece of equipment, and also that it's assembled and installed in a precision manner. We want to do a life cycle cost analysis at this point as well, because when you're selecting equipment, the life cycle cost is what's going to determine how much money you spend throughout the life of the machine. Fourth, we want to design for maintainability, and I talked about this a little bit earlier. We want to make sure it's easy to work on, easy to access. The next phase would be to discuss reliability issues during procurement. We want to minimize life cycle cost. We want to assure that the most reliable materials of construction are used. And notice that they don't say cheapest materials of construction, the ones that provide the most reliability. And also minimize life cycle cost. Third, we want to make sure that the purchasing specifications are followed. In best practice purchasing situations, there's usually a shared risk clause built into the purchase agreement, so that if the machine doesn't perform up to specifications, the supplier of the machine is held responsible as well. Fourth, qualification of vendors. If you have expectations beyond the sale of the machine from your vendors, you need to state those clearly in the contract and make sure that you qualify the vendors to make sure that they're capable and willing to provide the service that you need. Step 3. During the initial installation or acquisition of the equipment, we have some other items to address to increase reliability of the machine throughout its life. First, We can do a reliability-centered maintenance analysis on the machine and make sure that we document all the possible things that we would need to do to make sure that the machine has a long life and is very reliable in operation. What things would the maintenance department need to do to make it reliable at the lowest possible cost? Next, we would identify the failure modes and effects in a failure modes and effects analysis. These things can be built into your computerized maintenance management system while the machine is still being installed to make sure that when you start writing work orders against the machine, all of the different failure options are already there. Third, precision installation. This is really critical. If you're going to put in a new piece of equipment, at least you can install it in a situation so that the machine has the best chance for a good long life. And there are a lot of things to consider here. First of all, cleanliness. Alignment is very important, and you need to take a look at this because if your alignment procedures at your plant are a few years old, you can find that there are some really good new technology tools out there. Laser alignment's not that new anymore, but there are some really good tools that make it much easier and mistake-proof. But you want to make sure you do a good job with alignment. If it's rotating equipment, you want to do a good job on balancing. This is something that a lot of people don't know, but equipment that comes directly from the manufacturer is often not balanced to a very tight specification. You might want to take a look at installing your own balancing equipment or having a balancing company take possession of the machinery before you get it and make sure that it's balanced to at least an API 1.0 balance spec. Fourth, performance tests. Well, when you're going to do the installation, you want to make sure that you do certify that the machine can perform up to the standard or capacity that it was designed to do. And this kind of goes back to my discussion about having the vendors be qualified and also to have a performance clause in your contract. Because if the machine's not performing on day one, it's not likely to perform on day two any better than that. The next step would be to do things for reliability that are needed during startup and operation. First off, there should be a detailed commissioning process, startup, and operating procedures, constructed completely to support the equipment. You should institute an operator basic care and tour requirements package. In other words, some basic preventive maintenance tasks that the operators can do themselves to keep the equipment reliable and operating at its top performance. Total Productive Maintenance covers this in great detail, and I encourage you to look there for more information. Next, operator condition monitoring of the process and equipment. The operators are your eyes and ears initially on all equipment failures and equipment problems. They're running the equipment every day, so if they notice something different, it sounds different, it smells different, it's operating differently, we need to communicate that to maintenance as soon as possible. Fourth, focus on excellence during shift handover between teams. As always, communication is very important, and the handoff between shifts is an opportunity for good information to fall between the cracks. So you want to make sure that you have that covered with a good overlap and handoff. Last, there needs to be good solid teamwork between operations, maintenance, engineering, and the supply stream staff to maintain maximum reliability of the process. All of these groups have to work together, and if you remember back a couple lessons when we talked about the target, where everyone should be aiming at the low-cost producer goal at the center, you're not going to get to that goal unless everyone's working together and the needs of all four groups are being considered in decision making. Now let's talk about what you would do during maintenance activities throughout the life cycle of the machine. Now that it's been properly procured and installed according to precision maintenance techniques with all the bases covered, it's in operation now and it's part of the daily activities of the maintenance and operations department. First, we need to do reliability-centered maintenance analysis like a living program. In other words, once you put it in place and you've gone through an analysis initially, it's not over. Reliability-centered maintenance analysis can be done as a refinement program throughout the life of the machine. As you learn more about how it operates and the things that it needs, you need to build that into the program so that maintenance gets better and better as time goes by. Also, detailed procedures need to be sustained by a continuous improvement program. I highly suggest you build your maintenance process so that continuous improvement is handled automatically. In other words, if you have standard operating procedures and standard maintenance procedures in your system, They need to be getting feedback from the work order system and comments from the field as people work on the machine and operate the machine. And those things need to be pulled together and handled by follow-up. Normally this is done by the maintenance planners in most operations because they have good access to the information, and normally they build the procedures from gathering information from maintenance technicians and operators. I encourage you to make sure that this continuous improvement technique gets added to your system. Now let's talk about a new topic. We need to cost justify and budget tactics selected for implementation. First, we need to establish resource requirements to implement maintenance tactics. This is something that should be familiar to you by now. We've talked about this in the past already. So we need to determine the potential cost of unreliability. And we looked at some slides that showed different places where unreliability can come from in a process. First of all, one of the costs of unreliability is the repair cost itself. You can calculate that based on information readily available in your CMMS. Second, the cost to repair collateral damage. Oftentimes when you allow breakdowns to control your process, breakdowns create more breakdowns or failures downstream in the process that are much more costly than the breakdown itself. Keep an eye out for this because these things are truly caused by unreliability. Lost opportunity cost. If your process is running along smoothly and you get an order for a product and you can actually accommodate the order through your process without causing any interruption, that's great. But if you break down, you've lost an opportunity to make money. So breakdowns create a lost opportunity to produce product that you could sell on the market and make profits. As everyone knows that manages a business, you have some fixed costs to cover, and if you're not managing your process so that you get maximum productivity, then your fixed costs are going to eat up more and more of your profits. Last, product replacement cost. In some cases, if you have unreliable equipment and breakdowns to the point where you can't produce at the volume you need to satisfy your customers, you may have to spend money to replace the product from another facility within your company or even from a competitor. This is an ugly situation. You also need to allocate resources to reduce the cost of unreliability. Well, this is a really key point because most operations that are in reactive mode feel that they don't have any people available to put on unreliability efforts. Well, if you don't, you're never going to get out of the situation that you're in, and you're going to chase breakdowns and emergency work infinitely. First, you need to provide time, both internal and external. In other words, internal staff needs to be working on it as a part of their normal job. And if you need external resources to help you, you need to bring them in when it makes sense. Second, you need materials and equipment to reduce the cost of unreliability. In other words, you need good tools, and you need good equipment to go in and actually do the analysis that needs to be done. If you need analytical equipment, you need to either get it or you need to hire someone who has it to apply it to your process or equipment. Third, skills. You can't stress this enough. If you don't have the skills to reduce the cost of unreliability, but you're trying to do it anyway, you're going to be unsuccessful. There's a lot of training involved, there's a lot to know, and experience is a key element too. So the skills need to be built and they need to be utilized on a daily basis. You need to spend the money to do this. Fourth, and I just mentioned it, money. It does cost something to put resources into play to reduce the cost of unreliability. Obviously, there is a cost in manpower, cost in equipment, and a cost in the support structure for that. Fifth, technology. Technology will magnify your ability to reduce the cost of unreliability. Technology is not a magic potion for making unreliability go away. In a lot of cases, it gets used improperly. You need to use the technology to magnify your skills, and the people within your facility will do what it takes to reduce the unreliability in your process. In cost justifying the tactics selected for implementation, you need to prioritize the costs to meet the business plan. You always have to work within the boundaries of your budget. Now here's an important point. A carefully planned project can actually fund itself in many cases. And I mentioned before that you can do things to reduce the costs so that you don't see a big spike in spending to establish your proactive maintenance program. Well, how is that done? First, you can stop doing non-value added work. Well, this sounds kind of ridiculous because most people don't feel that they're doing a lot of non-value added work. But I really encourage you to take a look at your process using some lean thinking and look at things that don't really provide any value to the customer at the end of the project. For instance, if you're doing paperwork and filing it somewhere and it's not being read by anybody, that'd be non-value added work. If you're doing things that could be done electronically in a manual fashion, try to make them automated and eliminate those from the daily activities of a person. Other things that you might want to take a look at would be project work. Project work is not maintenance work by definition. And if you're doing things to construct small projects and do things that aren't necessarily related to maintaining the current equipment, you might need to shift that work away from the maintenance staff either permanently or at least temporarily. If you have to use contractors in the short term, it's not a bad thing. You need to make room for getting the project done. Okay, next we can shift resources to proactive methods. As we talked about before, it's 4 to 9 times cheaper to do proactive work. So as your process gets stronger and you eliminate breakdowns and reactive maintenance, you can start doing more proactive work, which reduces costs and therefore frees up cash for doing more things to increase proactivity. The first step in doing this is to make sure that your emergency work that is coming through the system is actually emergency work. As you set up your system and build a prioritization tool and also an approval system for the work, you can really filter out a lot of the unnecessary interruptions to your proactive work. This saves money immediately. Third, eliminate by either selling or auctioning off excess spare parts and equipment. It's a good idea to take a look at your process and do whatever you can to simplify it. If you have excess equipment capacity, bring the equipment productivity up on one piece and remove the other. Anything you can do to simplify your process and make it less complicated reduces the maintenance load. Spare parts in the storeroom inventory. As you build your criticality table for your equipment and get a good understanding of where your high, medium, and low criticality equipment is, you can go through an analysis after building your bills of materials to find out which equipment can have less spare parts in storeroom inventory or have them completely eliminated. It's really important that you get the spare part inventory down in your storeroom, because while you have a lot of spare parts, all you're doing is fostering reactive maintenance. If you don't have a lot of spare parts, it really forces the organization to plan, because you can't do work without parts. Fourth, reduce catastrophic failures quickly. Well, that sounds pretty easy when you say it in a 4 or 5 word sentence, but reducing catastrophic failures isn't all that tough. We talked about in the past the Pareto principle. If you can pick out the items that are causing the bulk of your failures and consuming the bulk of your man hours, and you focus on root cause failure analysis and reliability centered maintenance techniques on those machines, you will reduce catastrophic failures quickly and by a large margin. So I encourage you to spend some time doing some analysis and getting rid of the chronic failures. Well, now it's time to execute a maintenance strategy. Well, the maintenance strategy that we so painstakingly put together over the last few lessons is ready for execution, so let's take a look at how we'll do that. Allocate resources for each element of the strategy. As always, the resources control how fast we can get the work done. So define everything that's going to be done very clearly and communicate it to those who need to know. Maintenance, operations, engineering, supply stream, the leadership at your site, and their role would really be to bring this information up another level to the corporate leadership too, as necessary. Next, make sure ownership is clear and reasonable for each of the steps and action items in the strategy. Everyone needs to understand what they're responsible for doing, and also what you're asking them to do fits into their workday. Third, manage the initiative like you want the maintenance program to operate at all times. What I'm saying here is, if you want a program in your maintenance department that's proactive, planned, scheduled, executed well, followed up on, and analyzed properly when failures occur, then you need to manage the initiative the exact same way. You're basically giving a miniature model of what you want to be to all the people at your site. So keep that in mind. You're the model. As we execute the maintenance strategy, it's going to be important that you ensure that each strategic action is brought to closure. Now that we've identified what those strategies are going to be and the action items inside them, and we've identified who's responsible for each action item, We need to drive this very carefully to make sure that everyone follows through and completes their steps very effectively. First of all, it's very important that we communicate with each other. If someone's struggling with their action item, they need to be able to freely communicate with those they need to help them. And you need to communicate with them so they understand that they're well supported. Track progress and the schedule as well. I would recommend that you have a strategy update meeting on a monthly basis throughout the year. And of course annually you're going to need to update your strategy action items anyway. So if you meet on a monthly basis, you can go through the action item list and the responsible parties and have them give an update on where they are and how they're doing as opposed to the schedule that they started with. If anybody's falling behind and needs a little help, you can divert some resources to meet the targets as needed. Remember to drive the project along and emphasize the urgency of it. Make sure that you keep giving people a good clear vision of what the results are going to be, because you're not going to see immediate results. So you need to keep making sure that you communicate the vision, because as I mentioned before, it takes a little bit of time to get the benefits out of the end of a proactive maintenance operation. So in the meantime, you need to make sure you give people fuel from somewhere else. Last, and this is a real important one to keep people motivated, give public recognition to the people that are doing the work. If you have responsible parties that are doing a good job on their strategies and the action items are getting done, make sure you put something out that communicates this to the site so they get a little bit of a slap on the back. So much of the time in a reactive maintenance organization, all the credit goes to people that fight the fires and solve the problems when you have breakdowns. You need to really get away from that. When you have breakdowns, it's something that you should be ashamed of, not something you should celebrate. So if you break down and you fix it, tell people thank you for the help in fixing it up, but don't turn it into a big glamorous event. Make sure that the people that get the credit are the ones that avoid failures and the ones that solve problems so that failures don't occur anymore. Next, we need to review the performance and adjust the maintenance strategy. As we've talked about many times in the last few lessons and will again in the next few, we're going to identify gaps between the actual and target performance. So let's review the planned maintenance activities. Are the maintenance intervals correct on work orders such as preventive maintenance that happen on a monthly, weekly, or quarterly basis? Normally, these intervals are not set based on what the equipment really requires, but rather operational difficulties or past history. I've seen this taken to the extreme. In one instance, I saw a preventive maintenance work order that was built that required a maintenance technician to stand physically next to an automatic control valve 24 hours a day, 7 days a week, and to repair any failures that occurred on the spot. This is no joke. It actually consumed 3 people on 3 different shifts to monitor this valve, and what it turned out to be was an operational issue that had nothing to do with the control valve. But this is an example in a reactive maintenance organization where the production departments will demand a preventive maintenance task be placed in the system, and they don't really understand what drives maintenance and reliability. So silly things get put in there, and it's really nobody's fault. It's a reaction to issues that are occurring in a sick process. Your process is the cause of at least 80% of the disruptions to your reliability. Remember that. It's not the people, it's the process. We're fixing the process, and we're training the people, and when we do that, we're going to see reliability come up in a hurry. Second, do procedures assure proper execution of the activity? Well, again, normally not. The procedures that most people are using to do their work are either canned instructions from the manufacturer or no procedures at all. And sometimes they're even just a make-work project where the procedures don't contain any valuable information at all and are nothing but a piece of paper saying fix the pump. Procedures need to be very clearly developed for the equipment in its specific application. The instructions from the manufacturer are only a starting point. Things that you've learned at your facility are added into those procedures, and techniques for doing the work on that particular piece of equipment are sometimes different than the manufacturer recommends. You need to take this into account. Your procedures need to be instructions that would allow the least skilled maintenance technician on your team to do the job perfectly every time. Some other places for gaps would be to review the predictive maintenance programs, or PDM programs. The question is the predictive maintenance program detecting known failure modes and saves justifying the PDM costs? Well, here's another situation where the predictive maintenance techniques are usually built on top of a defective maintenance process that's reactive in nature. Predictive maintenance is then used to try to catch failures earlier so that they can be planned. Well, this is kind of an error in thinking, because predictive maintenance is really designed to monitor equipment and identify when something changes so that you can plan and repair it on a schedule. It's really not designed, as it's used many times in reactive maintenance, to find a problem and then predict how long the production process can run to get away with something before they have to fix the failure. So, another thing to keep in mind is the predictive maintenance program is only going to provide value if it's built on top of a process that fosters proactive maintenance, because the idea behind predictive maintenance is to eliminate failures, not pass them on as long as possible. As we continue to review the predictive maintenance programs, the next question would be, are there additional technologies to add to the PDM program? Certainly, most facilities don't do everything that they could possibly do in predictive maintenance because some things just don't fit into the operation, and in other cases, the technology and the skills don't exist at the site to actually apply them. But let's talk about some of them. Vibration analysis is the most common predictive maintenance tool used at sites, and it can be used internally or hired outside using contractor resources. I don't think too many people are surprised by seeing vibration analysis as a tool. Another more advanced tool using similar techniques to vibration analysis in a different way is shock pulse analysis. It's more advanced, and it also has some applications that will allow you to specify what kind of defects are occurring, for instance, inside a bearing, right down to the last detail. I would recommend that you take a look into shock pulse analysis if you have a use for knowing very specific information about why a failure is occurring. Ultrasonic and acoustic analysis is another very common PDM tool. It has a variety of uses. One thing that I've seen it used a lot on is thickness testing on things such as boiler tubes and pressure vessels. It has a lot of applications. It also can be used for detecting defects in equipment. It's very common to see lubricant quality analysis being done as part of the predictive maintenance program. Lubricant quality analysis includes a lot of things, but some examples would include viscosity checks of the lubricant, lubricity measurement, checks for water contamination, and thermal breakdown of the lubricant. Lubrication is kind of the blood of a piece of equipment, and lubrication analysis gives you some real good windows into the maintenance and reliability side of your equipment. Part of the lubricant analysis technique also includes wear particle analysis and checks for ferrous metal contamination in the lubricant. There are other additional technologies to add to your PDM program, and these subsets of the lubrication analysis program are very useful for identifying what's going on inside of a piece of equipment. Another excellent PDM program tool is thermography. Basically, it's the use of the infrared spectrum to look at equipment and processes to find defects. It's very useful and traditionally used to look for loose electrical connections inside of cabinets and inside buswork. Second, it's very useful for looking for hot bearings and different surfaces on equipment. Another thing that it's very useful for in processes that use piping is looking for plugged sections of piping and also bridging inside of tanks and things of that nature. It has many other uses, and as it grows in technology and the cost of it comes down, new uses of it are being found every day. There are some excellent suppliers of thermography equipment out there. I encourage you to take a look at those. Eddy current analysis is another PDM tool. If you have boilers or chillers in your process or anything else that utilizes high pressure piping, eddy current analysis is a great tool. It basically passes an electrical field over the surface of the piping, and as defects are passed through this field, they provide some information on a screen of the eddy current analysis tool that can give them a pattern that allows them to identify cracks, bulges in the pipe, corrosion, and abrasion wear. Each of those different things looks differently in the analysis using eddy currents. Very interesting tool. It has very special applications. And if that's something that sounds like it would be helpful to your operation, take a look at it. Electrical circuit analysis is another PDM tool. This can be used in a variety of different ways, and it's something that you can take a look at if you have a need. Transformer condition analysis is another electrical PDM tool that can be used. Transformers have a variety of different things that can be measured on them, and in certain instances they are key high criticality pieces of equipment in an operation. Generally speaking, they generate a lot of heat, and they have cooling mechanisms inside of them, including lubricants and oils of different types. And some of these things can actually be quite hazardous if they're old, so I recommend that you make sure that if you have a transformer that contains PCBs, for instance, that you don't go tackling this without an understanding of what transformer condition analysis has for hazards and also benefits. Another part of the PDM program that you need to take a look at is, are the operators applying process trends and control charts to take a look at their process and using look, feel, listen, and smell as tools for finding equipment failures early. Do they do this routinely? If they don't, something needs to change with your process. This is really a part of the total productive maintenance picture, and it's something that you need to build on to build a good proactive program. So your operators really need to participate in the maintenance process. And I think most of them by nature tend to do this anyway, but it's something that needs to be built into their job descriptions, and they need training on it too to do a really good job. Here's a good question. Is the predictive maintenance and process condition monitoring program fully integrated with planning and scheduling? In a lot of cases, organizations will build their predictive maintenance and condition monitoring program separately from everything else in their maintenance operation. And this little group will work autonomously away from everyone else, identifying problems and generating work orders or some other kind of exception report to tell the maintenance department that action needs to be taken. I would highly recommend that you integrate these groups directly into your planning and scheduling group. Let's talk about why. Predictive maintenance tasks should be planned and scheduled from the beginning, so everything that this predictive maintenance and condition monitoring group is doing to identify problems with equipment should be well planned with a good procedure, and it should be scheduled on a routine basis so that everything is tracked by time and date and also the resource that did the work. Why would we want to do this? Well, if you don't have a good procedure written up for the predictive maintenance tasks, then you really don't know if it's being done the same way every time in a qualified manner, and you also don't have a method for tracking whether it occurred unless you build it into your CMMS or some other tool. Next, follow-up work from planned and scheduled work should include root cause failure analysis as appropriate with help from the predictive maintenance team. In other words, the planners and schedulers are going to build planned work, they're going to schedule planned work, and then when this work gets executed, there's going to be a general amount of follow-up coming back from this work that requires some assistance from the predictive maintenance team. Why not integrate them into the group? Last, action items from the root cause failure analysis efforts should result in planned and scheduled work orders to execute the repairs and modifications identified by the root cause failure analysis. Now we're coming around from the other direction. The predictive maintenance team is actually going to generate work to solve problems permanently. So why not include them in the planning and scheduling department? It just makes sense. Another aspect of the maintenance strategy is to identify best practices and technologies to improve equipment reliability. We've talked already about benchmarking, the use of trade associations and professional societies like SMRP, and industry standards and specifications. It's very important that you take a look at this and find some benchmarking data that really will give you a picture of where you could be if you were the best in the world. Audit performance and compliance with maintenance and reliability initiatives and programs. The first thing in doing this is to build a best practices master document. If you don't know what the best practices are that you're trying to achieve, then how do you know where you're going? The best practices should be driving what you're doing with your strategy plan and also what you do on a day-to-day basis. You should be moving toward the best practices and constantly refining the best practices as new technology moves them along and makes them more and more advanced. Second, construct an assessment tool to measure progress toward achieving best practice behavior. Assessment tools are important because at least annually you should be doing a full site assessment to find out where you are with respect to your maintenance and reliability goals. It's going to take more than 1 year to get this done. In fact, it's going to probably take you 3 to 8 years to complete your reactive maintenance transition over to a proactive role. It'll go faster if you're organized, and that's what I'm hoping you'll get from this lesson, these lessons 1 through 9. But let's keep in mind that this assessment technique needs to be developed very carefully, because you're not just measuring yes or no, is it getting done or is it not getting done, but you're measuring on a continuum of whether it's being done a little bit, or done very well. These assessment tools exist. Many consulting companies have them, and I have an assessment tool in my consulting practice that I use quite often. I encourage you to spend some time doing a good job on your assessments. Last, conduct the assessments and communicate the results. An annual basis is probably the best. You don't want to be doing it constantly because it does take a lot of time, and it's also a little irritating as you collect the information to have people answering questions all the time. So do the assessment so it's meaningful, but don't overdo it. Communication of the results should be done, as we talked about before, to match the audience. So if you're communicating with the maintenance team, the picture might be a little bit different than how you communicate it with operations, engineering, and the supply stream staff. Make sure that you tune it to match the audience. I showed you this spiderweb chart back a few lessons, and I just want to show it to you one more time, because when you do the site assessment, this would be a great tool for showing the overall results of your assessment on an annual basis. Do it the first day you start the project to get a good idea of where you're at as a benchmark, and then every year add a new trend line around this spiderweb chart, and what you should end up with is a spiderweb chart that continuously grows outward toward the outer edges of the chart axes until you've got it fully inflated. If you get that all the way out to the edge on all 8 of these axes, you're doing a great job. This should be no stranger to you. We need to adjust as required to close the gaps. Some of the action items that you build for doing your proactive maintenance program will be easy to achieve. They're going to be like falling off a log, and they'll be very simple for your organization to adopt, and there'll be very little difficulty and pain in getting them accepted. Other action items will be very difficult for you to do. Generally speaking, the ease or difficulty of doing the action item doesn't necessarily correlate with how much value or benefit you're going to get from it. So I encourage you to work on all of these action items, be happy when they're easy, and when they're difficult, put all the resources you need to on them to drive them to completion. Sometimes the difficult ones are where the payback is. Difficult tasks will sometimes become easier as the process matures. For example, some of the things that I pointed out that are difficult for organized labor and unions to accept will get easier as trust improves with the proactive maintenance process. For instance, if you'd like to adopt a basic care program for your operators to do basic maintenance on equipment, this might be received very coolly by the maintenance labor union as well as the operators labor union early on. But as you get better and better at doing the process and they start to see that reliability is improving, productivity is improving, profits are going up, and job security is improving, the acceptance of doing TPM as a part of the maintenance program will probably also get easier to discuss. Take your time. Sometimes it's easier to let the difficult action items wait for just a little longer until some of the other ones have been accomplished. But last of all, don't give up, and don't let anyone tell you that we tried that and it didn't work. Using root cause failure analysis, you can do this, and you try again and again until you get it done. If something didn't work in the past, there's a reason that it didn't work. Try to find out why it didn't work, eliminate that problem, and keep working toward getting all of the action items in place. It's just not good enough to say we're not ready for that, or we're not interested in doing that particular best practice. If it's a best practice, it's a best practice, and you should try as much as you can to get it adopted at your site. Another aspect is to analyze the system or equipment failures as required. Doing analysis is what you do after you identify the gaps. So let's develop a process to qualify failures for analysis. Obviously, it's not going to make sense to run every single failure that occurs on a given day through analysis. It would just take too much time and the payback would be too low. If you have a failure that's obviously caused by something that people understand and it can be corrected, then no analysis is needed. But let's generate a top 10 list of failures that are occurring that really require analysis because they're chronic problems, they're very expensive or catastrophic to the program, or different special causes are making them very disruptive to your process. Pull information from your computerized maintenance management system to support this list. And last, don't forget to use common sense. This slide is a repeat of one I showed in a previous lesson, but the PDM top 10 list is an important concept. If you continue to focus on the top 10 causes of different disruptions to your process and you work hard to eliminate them, you're going to see an increase in reliability much faster than if you try to eat the whole elephant all at one time. So look for the top 10 causes of lost production, the most costly machines to maintain, the consumers of maintenance time, and the causes of product defects. You're going to reap the rewards much faster if you focus on the ones that are causing the most disruption. Another important aspect of the analysis system is a process to transfer failure analysis findings back into the maintenance strategy. We talked about this just a little bit in saying that the process should have the predictive maintenance folks built into the process for planning and scheduling. There's nothing more important than doing that to make sure that your failure analysis findings are getting back into the work orders. The work order system should be used to execute the fixes found in failure analysis. Last, there should be a training program to educate operators, engineers, and maintenance staff about how analysis is done and how the findings get back into the process to be resolved. Well, we're at the end of Lesson 5, Equipment Reliability 2, so let's take a look at a summary of what we covered. We took a look at what it takes to design a maintenance strategy that assures the production team of success and benefits. And I think we covered that in enough detail for just about anyone. It was something that carried on from Lesson 4. It's a fairly big chunk of information, so I encourage you to take a look at it again if you have any questions. Second, we talked about justification of all tactics for implementation using the facts. As I said before, you're going to be challenged on some of these implementations. You want to make sure that you have the facts to support your position. Third, you need to apply a workflow process and a maintenance strategy and stick to it. It's a lot of work. It's very difficult for people to stay on task, particularly early on in the program because the results aren't evident, but you need to keep them on track. As the champion of the process, that's your job. Fourth, measure the performance of the process and adjust for maximum return. Not everything is going to work the way you expect it to, so make sure you're ready to catch those things and adjust for them and generate maximum return at all times. As with everything else we've talked about, the payback is everything. Let's look ahead to what we're going to talk about in Lesson 6. Lesson 6 is going to cover Pillar 4 of the SMRP standard, which is people skills. Some of the objectives that we're going to achieve are assessing the organizational competence, developing a winning organizational structure, developing staff for the future challenges of proactive maintenance, and communicating maintenance skills and abilities to the customers. In other words, public relations. It's going to be an interesting section. I look forward to speaking with you about it. Congratulations, you've completed Lesson 5 of 9, Equipment Reliability 2. Thank you for your time, and I'll talk to you again soon. Have a good day.